Good morning, students. Today I am going to take spin splitting. This is a very important question, examination point of view. For this, I'm taking this example. This is one dash dichloro 2 chloroethane. Okay. Here we are having two type of protons. Both are chemically and magnetically different. The chemical shift of these two protons are very far away. So the spectrum will belongs to first order spectrum. Okay, we call this as AX proton. Okay, AX protons. Okay, here chemical shift is far greater than coupling constant. This will comes in first order spectrum. Now, when you look into here, this Ha proton, since it's attached to two Cl atoms, because of the two electronegative group, this is more de-shielded, appear at downfield. The CH2 proton attached to one Cl will appear at upfield. Okay, now the CH2 proton, this has to appear as singlet. The CH2 proton has to appear as singlet. But because the CH2 interacts with the HA in two spin states, this CH2 comes to resonance with this proton, the neighboring proton, twice, with this proton having clockwise direction as well as anti-clockwise direction. This CH2 comes to resonance twice. So instead of singlet, this appears as doublet. In similar manner, the CH proton, this has to CH proton, this has to appear as singlet. But because of the influence of CH2 protons, there are two protons. Okay, two protons. Because of the two protons, this will appear as triplet. This will appear as triplet. See the two protons, CH2 protons, the clockwise direction. Similarly, it will be anti-clockwise direction. Then one spin clockwise, another spin anti-clockwise. So the H proton comes to resonance, the CH2 protons, okay, the CH proton comes to resonance with the CH2 three times. One time it will be both clockwise, next time it will be anti-clockwise, in another clockwise, anti-clockwise, and vice versa. So the intensity will be 1:2:1. In doublet, the intensity will be 1:1. Okay. Now, by simple Pascal diagram, we can speak about the intensity. For example, the CH proton, which has to appear as singlet. But when one proton comes and interacts, what will happen? This will becomes one proton interacts, n plus 1 rule. It will appear as doublet. It will appear as doublet. When another proton comes for interaction, we will have triplet with the intensity ratio 1:2:1. When we have another proton interaction, 1 3 3 1. Okay, when we have only one proton, it has to appear singlet. When we have a neighboring one proton, it will appear as doublet. When we have two protons, it will appear as triplet. When you have three protons as neighbor, then we will have quadret with the intensity ratio 1:3:3:1. Simple Pascal diagram we can draw like this also. Okay. One is to 3:3:1. This is simple Pascal diagram.